Every year, hundreds of millions of birds travel thousands of miles each way between their summer and winter homes. And somehow they always find their way, never getting lost. But how do they do it? Hi, I'm here with Minute Earth. And you might think that getting lost on a really long walk is hard. I mean, just try walking across the United States without any maps or a GPS. But for birds, navigating across continents is easy peasy. And we humans are just now starting to understand how they do it. The amazing thing about bird migration is that it's one of the most awe-inspiring examples of animals traveling in groups, also called a flock, that we know of. Every year, lots of different species from swallows to geese to warblers leave their home territories to travel thousands of miles to their wintering grounds where there's more food and better weather. And the whole trip can take weeks. Along the way, the birds fly up to 60 miles per hour, covering between 40 and 60 miles each day. And they do all of this without getting lost, which seems impossible, especially because many of these birds don't use the same route every year. So how do they find their way? Well, scientists think they do it in two main ways. First, birds have excellent spatial memories. Like many animals, birds have the ability to remember what the landscape around them looks like from different angles, including from above. And when they're learning how to fly, young birds will often take orientation flights where they fly with adults and get a lay of the land. So if a parent and baby bird fly over a river delta, the baby will memorize the angle between the river and the sun to help it find its way back. This kind of spatial memory is thought to be important for helping birds navigate during migration, but it doesn't explain how they keep from getting lost when they're flying over unfamiliar landscapes. To figure out how birds deal with this, researchers at the University of California, Berkeley set up an experiment. They took 10 white-throated sparrows and raised them in a lab with a large outdoor aviary. Half of the birds were allowed to go on orientation flights while the other half stayed in the aviary but could see out of it. Then the researchers released both groups of birds and tracked their migration routes. The birds that had been on orientation flights flew directly to their destination, while the flightless birds flew around like crazy, often in circles, before they finally got there. And the researchers realized that the flightless birds weren't necessarily taking longer routes. They were taking many routes. These results suggest that the spatial memory approach to navigation isn't enough on its own to get a bird from point A to point B. The birds need some kind of map to compare their remembered routes to in order to get on the right path. But what kind of map? Well, one possibility is that birds use the stars to navigate, sort of like how sailors use the North Star to orient themselves on boats. But birds don't seem to use the stars for migration, probably because the stars don't move much in the sky unless you're a bird. Flying at 60 miles per hour, a landmark that's 2 degrees of angle away will pass by much faster than one that's 2 degrees of angle away. So a bird would have to take into account the movement of the stars relative to its speed. And while that seems super complicated, we now know that star maps aren't necessary for birds because they can navigate even at night and even in cloudy weather, which means they must have some kind of map that doesn't rely on celestial bodies. And that brings us to the second main way that birds navigate during migration, by using Earth's magnetic fields. Every moving charged particle, like those in our planet's core, creates a magnetic field. And although Earth's magnetic field isn't perfect, it's strong enough that birds can sense it. We don't know exactly how birds sense the magnetic fields, but it seems likely that they have special magnetic receptors in their eyes and brains that can detect changes in the magnetic field. And to calibrate those receptors, they use the sun, the stars, and the Earth's horizon. That way, when they're flying, they can compare their magnetic map to the visual landmarks around them and know exactly where they are and where they need to go next. Thanks to these remarkable adaptations, birds are free to roam wherever they please, which is great news for migratory birds, but maybe not so great news for the birds that live in your yard. If you want to learn how to make your yard less hospitable to birds that eat your crops or poop on your patio, check out the resources in the description.